So let's say he didn't give you your resistance arm, but he gave you everything else, and he's asking you to solve for your effective resistance force.
2 steps.
Good, perfect. Looks like you're 100 steps ahead of me. So you would use this equation to be able to find your resistance arm, and then you'll be able to get your effective resistance force.
Okay.
Can you talk about relative speed? I didn't catch all of what he said in class.
So from what I recall, Colony says he wouldn't split hairs with you. He's not going to have like something like 1 compared to 1.2. And even so, if that were the case, if you had, let's say, 1 to 1.2, you're going to know that that's pretty darn close to each other. It's not going to be moving very much, right? But when you have 500 to 10, this is probably a huge exaggeration, that effective muscle pull has to deal with your muscle, and so the quickness of this contraction will be really fast. It would be like getting a feather and doing a bicep curl with it. So the difference between the two should tell you how fast that is.
He said the cutoff point was 2 times as much.
Oh, okay.
Right? Yeah, okay.
2 times
That's
it.
2 times.
Okay, yeah.
Then it's fast, I think. Okay.
That's something he never told us, but yeah, that's good. So if the opposite were true, then you would know that's an eccentric contraction because your effective resistive force is overcoming your effective muscle force. And you can tell.
For a second, like talk about the concentric, eccentric, and isometric with this equation.
So nothing's really changed from that one section way back in the day. It was like, I think, section 4.
Yeah.
Do you remember this?
Mm-hmm.
So when your muscle force is less than your resistive force, you know it's eccentric, right?
Yep.
When your muscle force is greater than your resistive force, you know it's concentric. And then when they're equal, we know that it's isometric. So you kind of have them here in your equation. There's just an E with it.
Instead.
Yeah, it just means how effective is it being during that contraction.
Okay.
So that's how you would know concentric versus eccentric. Does that make sense?
Yes.
So that's kind of going over the math portion. I jumped into that trying to explain this, and hopefully that made sense, Corey.
Yeah.
Okay. So are we good with, do you want to go over more examples?
I think that was really nice.
Did you find?
I mean, I
So you'll have a calculator, obviously. And just quickly, I remember the bonus question for colonies at least was finding the angle. And hopefully, I don't know if you guys have taken trig yet or anything.
Invert.
Yeah, inverse sine. So you would put everything over on one side, take the inverse sine of theta, and then take the inverse sine of that.
Okay.
Do you want me to go over that real quick?
Yeah, sure.
Okay.
Let me grab a calculator.
So if we had all these values given to us, and he's saying, give me the angle of muscle pull, this would be that angle that you would use. Then you would take, let's say, our EMF was 50 newtons. And then, so I'm just going to divide everything over right now. Hopefully everyone's okay with that. Okay, so we have our force, our effective muscle pull will be different. It'll be, let's say, would it be something larger? or smaller. So we have 50.1. We'll say it's 5-ish. Divided by 50 newtons. Divided by 0.1 equals sine theta. Okay, so I took this equation, threw in some values that you would have already figured out from a problem before, and then so I'm dividing my F and FA over to get sine by itself, and then I take sine, the inverse sine of each side.
So that top number, should that be 5?
I'm sorry? No, so this would be something that you had solved for with sine being 1.
Okay.
I think that's kind of what he told you, that he wasn't going to do that. He wasn't going to make sine be
Anything other than
1, yeah. Is that true, colonies, people?
I think that's true.
Probably.
I have it in my notes, and I recall that's what it was for us.
Sine other than 1. We mean 90?
Sine of 90.
Yeah, sine of 90. It would just be 1.
No, it's on there. You have a different sign on the next thing.
Well, if you're trying to find an angle, though, you have to have all these variables given to you. That's what I'm saying. And so then, whatever those variables were given to you, you would just take the inverse sine of those variables to get your angle. If he gives you a different angle, just know to plug that angle in its appropriate spot. So this is your angle of resistance, and this is your angle of muscle pull.